So guys, we have seen till now that displacement time graph of a particle depends on its direction of motion. Suppose this is positive x direction, this is negative x direction. So this is the graph traveling for the particle with a uniform velocity along positive x direction, whereas if it travels in negative x direction, the graph would be like this. Okay, we have seen this. It also depends, displacement time graph also depends on initial position of the particle. Suppose a particle at time t is equal to 0 starts at some point other than 0 0 and moves with a uniform velocity, then its graph will look like this or look like this. Okay, so we will now see how the magnitude of velocity has an impact on displacement time graph. Displacement time graph. Okay, so suppose this is x-axis, positive x-axis. Okay, and this is time t in seconds. Suppose a particle initially at time 0 is at coordinate 0 O. Okay, suppose this point is O and it moves with uniform velocity and reaches 20 meter. Here it is 20 meter 20 meter in time t is equal to 10 seconds. Okay, then its graph would be like this. Okay, suppose this is 40 meter and this is 60 meter. So suppose the particle increases its magnitude of velocity, then in the same time t is equal to 10 seconds, it will cover more distance. Okay, so suppose this time the particle covers 40 meter in 10 seconds. By increasing the magnitude of velocity. So this graph would be like this. Similarly, for 60 meter, this graph would be like this. So we have seen whenever a particle moves with a uniform velocity and it increases its speed, magnitude of velocity, then its graph becomes steeper. Okay, you are seeing this. Similarly, as we know that velocity, average velocity is equal to change in displacement by time. That is, to increase the magnitude of velocity, either you will have to cover more distance in same time interval, okay, or you will have to cover same distance in less time. So in this case, we have seen that the magnitude of velocity increases by covering more distance in same time interval, and graph is looking like this. Suppose now we will see this is time t in second, this is positive x-axis, and the particle moves along positive x-axis. Here it is t is equal to 5, t is equal to 10 second, and t is equal to 15 second. Here the distance is t is equal distance is x is equal to 40 meter. So suppose as time t is equal to 15 meter, the particle is at 40 meter, and initially the particle was at 0 0. Okay, then its graph would be like this. Suppose same particle starting from 0 0 covers 40 meter in lesser time, and this time it's covering the distance in t is equal to 10 second. So its graph would be like this. Similarly, for t is equal to 5 seconds, the graph would be like this. So we have seen in this case also the graph of a particle moving in a positive x direction with increasing magnitude has become steeper. Okay.